Okay, let's talk about the nomenclature of carboxylic acids and carboxylate salts. So you guys know that a carboxylic acid looks like this, okay? But a carboxylate salt is when a carboxylic acid gets deprotonated so that it has a negative charge, and then we have some kind of cation, oftentimes a sodium. Could also be a lithium or potassium, but I'll just put a sodium there. So we know that a salt, right? A salt has a cation and an anion. So that's something to look for in this video. All right, so carboxylic acids. And a carboxylic acid is an organic compound that contains a carboxyl functional group. And the characteristic functional group of carboxylic acids, like I just said, is the carboxyl group. And so the abbreviated forms of a carboxyl, sometimes we write it like this. Other times we put it as COOH or CO2H. They all mean the exact same thing. So I repeat, all three of these mean the exact same thing. So make sure you know the abbreviated forms. And carboxyl containing compounds are abundantly found in nature. For example, the tart flavor of foods that taste sour is generally caused by the presence of one or more carboxylic acids here. And you see they have some lemons and limes down here in figure 10.15, which are citrus fruits. And citrus fruits contain citric acid. And the acids in or the acid in citric acid is a carboxylic acid, okay, that causes that tartness. And also later on, we're going to look at propionic acid or propanoic acid, this acid here, a carboxylic acid with three carbons in it. And if you like the tang in Swiss cheese, it comes from propanoic acid. So oftentimes foods that are sour, we owe that to carboxylic acids. All right, so here are some examples of carboxylic acids, and this is propionic acid, which is the common name of propanoic acid that I mentioned on the previous slide. It has one, two, three carbons in it, and they say here it's used as a mold inhibitor, which it is, but like I said, it also provides the tang in Swiss cheese. If you look at a one carbon carboxylic acid, one carbon, the common name is formic acid. And the IUPAC name would be methanoic acid, right? Methane for one carbon if it's an alkane, so methanoic acid. And methanoic acid or formic acid, it says it's used as the stinging agent by certain ants and nettles used in food preservation. And Mr. Dion doesn't speak Spanish, but I do speak French, and I know that in French, ant is fourmi, which is related to formic acid. So that's where the name comes from, which comes from ant and the fact that they have this defensive spray. Okay. Next one is acetic acid, and acetic acid is also known as ethanoic acid. It has two carbons in it. That's the acid that's found in vinegar. Next, they've shown here oxalic acid, and oxalic acid has two carbons in it, but it has two carboxyl groups in it, right? Two carboxyl groups in oxalic acid, also known as ethane dioic acid. And it says here that oxalic acid is present in leaves of some plants like rhubarb and spinach. And if you've ever bitten into raw rhubarb, you know that it is sour, okay? Next one is citric acid, and I'm sure some of you have taken biology classes and studied the citric acid cycle. And you can see here that citric acid has not one, not two, but three carboxyl groups in it. And again, it's present in citrus fruits, and it is what's responsible for the tangy or sour um, taste in citrus fruits like lemons and limes. And then the last one that they've put here is lactic acid, and you might know that lactate builds up in muscles when a person gets tired. But anyhow, lactic acid, you can see here, it has one carboxyl group in it. It's found in sour milk. Okay, so when sour or when milk rots, the acid that builds up in there is lactic acid. It's also found in sauerkraut. And like I said, it's formed in your muscles during a strenuous exercise. All right, keeping in this theme of common carboxylic acids, you see vinegar is shown here in this figure, and I told you that acetic acid, so acetic acid, which is CH3, C with a carboxyl group, okay, that's acetic acid. Um, is the acid found in vinegar, and it's named after the word acetum, which is Latin for vinegar. And then it says here that aromatic acids are derived from benzoic acid, and so you should know the structure of benzoic acid, which is where we have an aromatic ring with our carboxyl group directly attached to it, so that would be benzoic acid. Then it says here the smaller carboxylic acids and long chain fatty acids were also given common names. So other carboxylic acids are named through the IUPAC system. So having the common name at your fingertips of acetic acid is handy. And you saw on the previous slide that they provided IUPAC names and common names. But we're going to talk about nomenclature using the IUPAC system. And then I'm sure that a lot of you have heard of fatty acids. And what a fatty acid is really, it's just nothing more than a carboxyl group. So it's just a carboxylic acid, but we have a long hydrocarbon chain attached to it. Okay, many, many carbons like this. And the reason we call it a fatty acid is obviously because it's got an acid portion, right? This would be the acid portion of a fatty acid. But if you zoom in here, this portion that's a long hydrocarbon tail here, we know that that is water hating, right? It is hydrophobic. And so this would be the fatty portion, right? Because fats are hydrophobic. So that's where the word fatty acid comes from. And fatty acids come from the hydrolysis of triglycerides. So if you think about animal fats, so animal fats are treated with a base to make fatty acid salts, and those are what's used in soap. So what's the IUPAC procedure for naming carboxylic acids? All right, so step one, we're going to find the longest chain that contains the functional group, which would be our carboxyl group. And the carboxyl group is going to be carbon number one if you only have one carboxyl group in your compound. All right. Then we're going to name that longest chain containing the carboxyl group. The final E of the parent hydrocarbon is dropped, and we replace it with oic and then acid. So if you have butane, it becomes butanoic acid. If you have pentane, it becomes pentanoic acid, hexanoic acid, so on and so forth. You're going to locate the position of the carboxyl group by the number of the carbon atom to which the double bonded oxygen is attached. Then you're going to locate and name any other groups attached to the chain, so a methyl or an ethyl or a chloro, bromo, fluoro, etc. You're going to combine the name and location of other groups, the carboxyl group location, and the longest chain into the final name. So what's the best way to master this? Really, these rules can be a little daunting when you look at them, but if you practice them, you will get good at naming carboxylic acids. And so let's see if we can name these carboxylic acids. Now, the first one has a total of 1, 2, 3 carbons in it. And if we had a 3 carbon alkane, right, like this, we would call that propane. And so what do? We drop the E and we replace it with oic acid. So the name of this compound must be propanoic acid, okay? That's the IUPAC name for this compound. Now, if we look at B, okay, B has a total of 1, 2, 3, 4 carbons in it. And we know that if we had a 4 carbon hydrocarbon, it would be what? Butane, right? Butane. So we're going to drop that E. And so this compound would be a butanoic acid derivative, but you see that you have a bromo here on the 3rd carbon. And so this would be 3-bromo butanoic acid. I'll just put acid down here. And then the last one is a carboxylate salt, okay? And I haven't gone over the rules for this in gross and gory detail, but the first thing that we do is we name the metal ion first, okay? So first thing you're gonna do is you're gonna name the metal, and then you're gonna name the carboxylic acid, but you're gonna replace the suffix from oic acid to O8. So instead of oic acid, you're going to place it to or replace it with 8. Okay. So instead of, since we have 1, 2 carbons, right, that would be ethanoic acid. And we have sodium as our metal. So we're going to call it sodium ethanoate. Ethanoate. Oop, I should have put the O in there. So sodium ethanoate, okay? Now, you also know this two-carbon carboxylic acid, right? If you had this acid, we've looked at this many times, we know that this is also acetic acid, right? Is the common name. And so you could also call this sodium acetate. So, or sodium acetate. So, like I said, carboxylic acid salts, we replace the suffix with "-ate," right? So, if you had the carboxylic acid derivative of sodium benzoate, right, which you know is benzoic acid, so right? This is benzoic acid. So we listed metal cation first, so it's sodium, and then instead of benzoic acid, it becomes sodium benzoate. Okay, so there you go. So carboxylic acid salts are solids at room temperature. Why? Because they are salts, right? They consist of a cation and an anion, and we know that ionic compounds are usually solids at room temperature. They're also soluble in water. Why? Because they're ionic, right? Just like sodium chloride is ionic, it's soluble in water. If you have a carboxylate salt, it consists of a cation and an anion, and so it's also going to be soluble in water. Now, long chain acids with an extensive nonpolar hydrocarbon portion can be solubilized by turning them into salts. And I told you earlier on what a fatty acid looks like. So if we take that acid group and we convert it into a salt, like this would be a fatty acid salt. And a number of fatty acids, or sorry, a number of acid salts are important around the home as soaps and preservatives. And what I've drawn here, this fatty acid salt, this is essentially the formula of what a soap looks like, okay? This is the structure of a soap. It has that long hydrocarbon tail, and then you have a carboxylate salt on the end with the carboxylate salt. So sodium benzoate is a common food preservative. It's found in bakery products, ketchup, carbonated beverages, and a host of other foods. And so I encourage you that if you're eating, ketchup with your meal, look at the ingredients, and it will probably say sodium benzoate on the label, also with carbonated beverages and many other foods. So, one time I was looking at sprinkles. My kids were putting sprinkles on cupcakes, and I said, "Oh, what's in these sprinkles?" And I noticed sodium benzoate was in there right away. So we see sodium benzoate is oftentimes used as a preservative.